Hi, this video will try to explain what files really are. So let's look at the file that we have right here. So I have Notepad here, I have an untitled document, and I haven't saved this file yet. We have some letters here, like W, H, A, T, and so forth. And right now they're actually in very, very big here. If you look at that, we can go in here and we can change the font so that we can make it something else like terminal. We can make it bigger, smaller, whatever we want. So why is it possible to do this? So what we're going to look into is what is files and what is Notepad actually doing to the file. So let's go back here and set some regular font here. So let's try to look at this file under a microscope. So let's take the file and actually save it to the computer. So I'll choose Save As and put the file on the desktop. And I will call it something like my file. And if you look here, you'll see that it says .txt, so that it will actually save it as a text document. And what that means, we'll see later. It also says here encoding. We'll look into that as well. And we can choose different things like ANSI, UTF, different kinds of UTF, and so forth. And the normal one is UTF8. Let's try to save it like that. So I'll save it to the desktop. I'll call it my file and I'll click save here. Okay. Then I'll get some help from a web page to really look at this file, because if I open this in Notepad again, I can go into, if I close Notepad, reopen Notepad, and open the file I just created, my file, we can see we can get the same result. But what I really want to do is I want to show that this is really not saved as letters in the file, and yet it is. So let me show you. So I go to this web page here where we can actually open the file up and see it in a different way than we can do in Notepad. Notepad is made for displaying text from files that are formatted in a way that we can read it. This is also what we call encoding, and in this case it's called UTF8 encoding. So this actually tells us this is UTF8 encoded, and also here it says it used something called Windows line feed. So it says CRLF means carriage return line feed. Let's come back to that. So now I'm going to open this file here. I go to the web page, say open file, find my desktop, open my file, and now we can actually see that it looks a bit different. So this editor here is different. So this will view it in different ways. So if we look at the first one here, it says something that looks like 57, 68, 61, 74, etc. And if I highlight one of them, we can actually see that 20 corresponds to a space over here, and 61 corresponds to A. And if we click the other A, it actually is the same number. So this is really because it's really just represented as binary. That means zeros and ones. And what this editor does is it actually shows this as a different kind of number that's called a hexadecimal number. This is why it says something like 6C here. So this is kind of a different way of viewing it, and it actually means that the number behind this W here is 57. So what basically happens here in Notepad is that Notepad reads the number 57 and then it displays W, capitalized W, 68. it's an H, 61, it's an A, etc. So it actually knows which numbers corresponds to which letters. And then we can think, how does it actually know this? Where does this number, how does that know that that corresponds to these letters? This goes way back in time, back to telegraphs and stuff like that. But the interesting thing is that these can be looked up in a table, and Notepad knows about this table. So when Notepad looks it up, it decodes the binary file using the UTF8 decoder. The UTF8 decoder is a somewhat complex way of representing characters. I won't go into that, but the first part of UTF-8 is exactly like the very old version, the very old encoding called ASCII. So let's look at ASCII because it's a bit more simple than UTF-8, and the first part of UTF-8 is the same, so we can directly compare it. So let me show you what I mean. So I searched the internet for an ASCII table, found this one on this web page here. And what you'll see here is you can see the different representations of numbers here. So we know that a W from here was 57. And as I told you, this is an hexadecimal one. So it's not like normal integers that you would see. So 57, let's go in here. And we look at the hexadecimal ones, 57. Here it is. That is a W here. And we can also see what it corresponds to in other kinds of number systems, like in the decimal number system, the normal number system that we use when we count. That is 87. We can also see that in here. 57 corresponds here as an 8-bit integer to 87. Okay. And in Octa decimal system, we can see it corresponds to something else. This is not something we use very often. And then in HTML, this is only for some web stuff, not relevant here. So we can see that if we want to change the capitalized W into a non-capitalized one, we need to use another hex value for that, namely 77. So if we go over here and change this into 77, it becomes non-capitalized, and we can go back to whatever letter we want. So it's kind of interesting that a number corresponds to a character. So that means that text editors are really just a way of representing binary data in a specific way. So if we don't know what kind of file we are dealing with, let's say we got a file from the internet with no naming that could tell us what it was, we would have a hard time opening it up because there's nothing in here that tells us that this is text. If you look in the raw file, you'll see there's nothing here, like there's no part of it that says this is a text file or anything. It just starts out directly with the data. So one of the reasons why I knew this was a text file was that when I saved it, I actually choose text document and it puts .txt behind it so that Windows know which program it needs to use to open this kind of file. If I encode it in some other thing like UTF-16 or something, ANSI or something, I could get into problems and I could lose information. These are somewhat interchangeable, but not completely. So actually, if we choose something else, we might not see what I intended you to see. So if I save it in UTF-16 and open up in UTF-8, I could get into some problems. So we need to use the same encoding for all files, and if you're ever in doubt with text files, UTF-8 is the way to go. Okay, so what this video is all about is understanding that whatever we see in the file really corresponds to a number. And that number is usually just a binary number. It's just zeros and ones saved on a disk somewhere. Another interesting thing to note is that for simple letters like this, we can see that they all correspond to only a single one of these. Sometimes in UTF8, complex characters can have multiples of these. So we can kind of combine multiple letters together to get more complex ones, like different kinds of smileys and stuff like that. But let's not look too much into that. But the interesting thing is that we need to look it up to see what letter we actually need to show on screen. This is also why I can easily, when I started out the video, I can easily change the font, because the font is just the way that we want to show our text. So that also means that there's no font or anything saved in here. If we open up a program like Microsoft Word, we actually save the font with the file, so that the font is kind of embedded in the file so that Word knows how to show this. So because I now changed the font, I haven't actually changed anything. If I save this file, the data will be exactly the same behind it, because you cannot save a font into UTF-8. Some other interesting things, we can see 20 is an easy one. That's a space. We can see it has a space here. And then here at the end, we have this kind of endpoint here. And I don't know, we cannot actually see, it just says end of file here. Let me just try to make some more lines. Line 2. Save that and then reopen the file. So what we can see here is there's some special character here, which really means that this is a new line. And it says 0D here and 0A here. So let's try to look at that 0D and 0A. What is that? If we go in here, and remember this is hex, so we have to look at the hex part and then go for 0D. That actually means carriage return. And the other one was 0A, which is the line feed. So it's actually character number 10 and 13 in our normal way of counting. These are the two that we use, and that's because at some point in Windows it was decided to use both characters, both the carriage return and line feed, for creating new lines in Windows. So that's why it says CRLF, carriage return, line feed, and the first one being 13 and the other one being 10, or in hex version we would call it 0D, 0A. And this is just like another way of showing it. So in all other operating systems, they only use one line break. So it's special for Windows that they use to. And this sometimes gives you problems if you open up a file that was written in Linux or Mac. If you open it up on Windows, you won't actually see the line breaks, because Windows wouldn't interpret that. Yeah. Okay, so that is an important thing to know, that everything is just data. So let's just open up like this Wordpad here. So Wordpad is kind of like Microsoft Word. So let's just type the same text in here. What are files? Maybe even copy it from the other one. I want to show you something. Copy this over here. Maybe just make it a bit bigger. Okay, maybe too big. Make it a bit smaller, like this. And I will save this, and it will We see there are different kinds of formats here, and there's something called rich text format, Office Open XML format. Let's try to save it in a few of them. So the first one, let's call that document and save that on the desktop. Save, and go into File, Save As, and then Office XML format. So now I have RTF and XML format. So let's try to open them up. And here, let's open up the Office Open XML first. So this is actually the same text. We see this and this is the same, but there is a bit more in here. And if what we actually see here is the same thing we would see if we open this up in Notepad. Let me show you. So if I open up this Office XML, we can see it looks the same up here, almost the same. It says PK and then some weird things here. Let me just do Wordwrap, makes it easier. So we can see these are some of the same. And it does have some things here we can read. And this is what happens. We can see it actually interprets this as ANSI and Macintosh carriage return. It tries to guess to see how do I read this best. But Notepad cannot read these kinds of files here. If I open up the other one, the rich text format, it does look a bit better because rich text format is really a text file where you put some codes in here to explain which which font you're using and stuff like that. And we can actually see in here, let me just make it a bit bigger. So we can actually see that we can read this because it is real text. So like this one over here, the docx format is unreadable in normal text. It's not really text. It's a specialized format that Microsoft has made for its document openers. So rich text format is a more open format where everything is generated as text and then interpreted. So that means if I open up something that is in RTF format, this one document RTF, I can open that up in my Wordpad here, and it will actually remember the formatting I've been doing. If I center things, or it will all be put in here and saved as a text file. So in this case, this is still just binary data. If I open that up, we still have the binary data, but we can see that as before, and A is 61 and so forth. So we can actually see this is UTF8 that we can open up here using UTF8. And we can also see that we can easily read this in here. It's not just mumbo jumbo stuff, but although it is text, it doesn't really look like what we see in here. And that's because it's an extra layer that we put on top of that. So where the Notepad actually reads the binary data and creates text, this does kind of a two-step operation where it first converts from the binary into the text, and then it actually interprets this text into what you see here on the screen. So this is a much more complex format than this one. And a lot of file types today are based on these kinds of text formats, some form of XML. You probably already know from, if we go to this web page here and I go view source, you can actually see this is also UTF-8. This could be read in Notepad. We wouldn't get the colors then. But we can read this in Notepad and we can actually see it's just a simple text file. And this is also when you do programming, you also write everything in simple text and then we interpret it afterwards. So this is just interpreted by the browser to look like this, although it is really only text. And of course, some of this text here, it refers to some images and stuff that are the images that we see here. But it's actually just the HTML file itself is just text. So a lot of formats do like this, and this is HTML is a subclass of XML, which is this way where we use this kind of diamond notation with these slashes and for starting and ending and stuff like this. This is XML format. And today there's also other formats like JSON and all kinds of formats for this, but this is very much used, of course, because the entire web uses this format for displaying web pages. So that's it. This is what files really are. And in the next videos, I'm going to show how to read and manipulate files from Java using different kinds of Java tools, and also how to read and manipulate binary data directly. So watch the other videos if interested in that.